observations of physical changes in different states of matter. The first column that we have here is where we listed our objects that we use for our experiment. The second column says state of matter. This column is going to be telling us what type of matter it is that we're working with in our experiment. The third column says the actual experiment. And in this column, the children were supposed to, you all were supposed to write about what you all actually did in the experiment. And the last column says physical changes. That's the fun part. That's when you're going to use adjectives, words that describe what you saw. A physical change is something that changes right before your very eyes. The first thing that you all got to experiment with was colorful Play-Doh. I would like my Play-Doh group to come up front. The object was colorful Play-Doh. What state of matter was the Play-Doh when you originally started the experiment? Solid. Very good. Actual experiment. Tell us about the actual experiment. What did you have to do? We had to make the Play. You had to make the Play-Doh into different shapes. Okay. What were your materials? Tell us about the physical changes. What happened right before your very eyes? Tyreek. Colors began to change. Okay. The object that you all got to experiment with was the colorful candy fish. What type of matter? What was the state of matter before the experiment started?
Solid.
Okay. The fish was solid. What was the actual experiment? What did you have to do?
We had to put water in the bag and watch it and see what it does.
And wait for a physical change. What was a physical change?
It faded.
The colorful candy fish began to fade.
The water changed color.
The water changed colors. The fish began to melt, break into pieces. The fish sank. Okay? It was not very heavy. Here says it was not much. What was the density? How close were the molecules? You said very close, like a, very close. Very close, that's why it's a solid. And what is the volume of your object? Did not take up a lot of space in the bag. Okay? Very little volume.
It took a little time for the water to turn fire.
The water to change. And if you can see here now, the fish are not the same color they were when we first put them in there. They have actually faded a great deal, haven't they? Yes.
And the color is blue.
They're not dark solid colors anymore, they're light colors. We've also been talking about mixtures in our science lessons this week. Today, I will also mix the baking soda and the food coloring. Stop. You all didn't have quite this much, did you, the other day? So let's see what physical changes will take place today. Okay? First of all, when we added the baking soda, what color was it?
Red.
What was the mass?
Red.
What was the mass? Light. What was the volume?
Not too close, but space.
Not that much space. It didn't take up that much space in this cup, in this container, did it? No. What about the density?
A little bit.
How dense is the baking soda? Like a solid, yes. The molecules are very close together in the baking soda. What about the mass of the liquid that I'm using, of the food color?
Light. The size.
Light.
Light.
Light in small droplets, because mass is the weight and the size. We also learned what molecules look like in science, haven't we? While we've been talking about matter, we learned that whenever they're tight and compacted closely together, that makes it a solid. Whenever the molecules are spread out just a little bit, they're spaced. When they're spaced out, it's a liquid. And we learned that whenever the molecules are when they're spread far apart away from each other, we call that a gas.
So it's turning orange.
It's no longer red food color, but the component is turning orange.
Like me.
Does it still look like baking soda?
No.
No, it looks like rock. Lots of rocks.
Orange and white rock.
It's actually hard.
It's physical change.
Very hard to, yes, it is physically changing right before our very eyes. Nasir, what have we learned about mixtures?
If you mix it, then it's going to cause a physical change because it depends on what you put in there.
It depends on what you put in there. When you're mixing types of matter, 2 different types of matter or 3 different types of matter together, it causes a physical change. And I want you all to watch this physical change. I'm going to add a 3rd type of matter. I'm going to add solid, liquid, or gas? Liquid. Vinegar. We're adding a 3rd type. What does the vinegar make this? What does the vinegar make this? These components change into once we add the vinegar into a gaseous form, and it also smells horrible, doesn't it? So we're gonna make a matter layered cake. All right, honey. This is cooking oil in here. Vinegar. Water, Mrs. Cox. Food color. Actually, would this be a solid? Remember what a liquid is. A liquid can form fast or slow.
It's a liquid.
It's a liquid. Notice this physical change. Something's happening here. What do you notice about the food color in the honey? The red is on top of the honey. So we've learned that the food color is sitting on top of the honey. Let's see what physical change the oil does.
Oh my gosh. It's coming up higher.
What's happening to the oil?
The oil is on top of the food color and the oil is turning a little red.
The oil's color has changed a little bit. It's sitting on top of the food color, and the food color is sitting on top of the honey. So how many layers do we have here?
3 layers.
The next thing that I want to mix is water. Do you think the little bubbles are the molecules?
Yes.
And what are the molecules doing? They're breaking up. They're breaking up, right? When the molecules start to spread apart, what does that mean? Yes. So are the states of matter starting to change? Yes, they are. The last thing I want to add is the vinegar.
It's changing. Changing into a let's fill in here now. I want to eat it. It's called.
What happened with the vinegar?
It smells like somebody took off their shoe.
What's happening with the vinegar? Did the vinegar form a layer, or do you think the vinegar mixed in with the water? Nayana?
It mixed in with the baking soda.
You think it mixed in with the baking soda? You always like to experiment.
Awesome.
And what's happening to the baking soda?
It's going down.
It was white, but now it's turning red. It's going down to the bottom, and the molecules are going crazy in here. Do you see them?
They're going dark red.
Listen. Shh. Let's whisper. Is the state of matter changing?
Yes.
What is the state of matter changing into? A gas. The molecules are going crazy. They're going upwards and they're breaking up like crazy in here. Why do you think the baking soda has done this at the bottom? Why do you think it has taken this form?
It's soaked down.
Because the honey made it stick together. Baking soda is so dense because the honey made it bunch up and compact tight together, right? Close together, right? So it's more dense. Does not have a lot of volume. We're talking about the baking soda at the bottom of the container. And what do you think the mass is of the baking soda at the bottom of the container?
Heavy.
Probably heavy because it's compacted so tightly together. And I hope that you all remember what matter is, and you remember why physical change takes place when you mix different types of matter together. See?